All right, in this video, we're going to start from the measurements that we gathered when we did the combo, when we were figuring out how far away and how tall an object was. In this case, we'll do a tree example. And so we're going to first start here with our distance diagram, and then we're going to look at our height diagram. So first, I've got very similar diagrams from the earlier videos. So here are two objects pointing at an object, two of my pointing devices, I should say, pointing at an object at a distance. I stretched my tape measure between them, figured out the distance, and then I used a protractor to measure the angles in each of those corners. And I need to determine, well, which distance was I actually measuring from? What is the distance I was trying to calculate? In the video, I had like this, let me use some other color, here, pink here to stand out. I just had some like little parking, I don't even know what to call it, like just a piece of concrete to keep the car from going past. Okay, and I was measuring from there in the video. And so if this is the distance I'm measuring, I highly recommend just, writing the letter D on that side to represent that's the distance between the object that I'm, whatever point I'm measuring from. It doesn't have to be from an object, but from whatever point I'm measuring it from to that object, in this case a tree, I'm going to measure it as D. And it was from that point that you were supposed to measure this angle up to the tree. It was from that point. So the key is that the distance, whichever side you label as distance, should be the one where you took your pointing device from that same spot, and that's where you pointed up. And if that's true, that means the distance from here to here is also D. And that's the key to this whole process, is that the distance you measure here, that you can't actually use a tape measure for, is what you're able to figure out here. And then you can call the height of that tree or building or whatever object it is, we can call it H for height. And now there's only a little bit more to do to fully set this up, and that is to figure out what all our angles are. So what I need to remember is that all my angles add up to 180, so I'm going to take 180. See if this is in screen there. And I'm going to subtract my other two angles. So minus 87, minus 89, and that would give me a 3-degree angle up top. And down here, I need to do the same thing. But down here, since we're talking about height, we're talking about something that is straight up. And so if our ground is level here, this is a right angle. So that's 90 degrees. So then if I do the same process, 180 minus 90 is 90, and then minus 12 would give me 78 degrees. So that would be this here. And if you were to actually look at my diagram is not to scale. If I were to try to draw this to scale, the tree would look a lot shorter, or would be significantly farther that way, which I can't really point to that direction, because obviously this in my measurements, this angle is a lot smaller than that angle, but in my diagram they look about the same. So, but that's okay. Your diagram does not have to be perfectly to scale to solve. And so there we go. This is all the information I need now to go solve. So I set it up by drawing the same diagrams as I did before, and the only key difference here is that the distance that I measured, that I'm trying to measure here, should be the same spot at which I measured my angle up to the top of that object. And if you do that, you've set up your diagrams and are ready to solve.